So as I'm recording the notes for today, if any of you decide that you even want to go back and watch it, even if you are here today, it's going to be weird because you'll hear my voice, but if any of you ask a question, when you're watching the video, you won't be able to hear any questions asked. So I'll try to restate questions if you guys have a question today. Otherwise, you won't be able to hear that on the video. So we're going to go ahead and do, like I said, the warm-up as part of our notes today. If you want to, you can just build it off of right where we left off yesterday. We did 7 problems, I think, yesterday. So this would be our 8th example. Okay, so our warm-up was 2 times the quantity x plus 1 to the 4/3 minus 8 equals 24. So what was the first step you guys did on the warm-up? Good. Add over the 8 to the other side. And then what was your second step? Divide by 2. That would have left you with x plus 1 to the 4/3 equals 16, because 24 plus 8 is 32. And if you divide that by 2, you'll get 16. What did you try doing from here? What did we do from here? Crystal, what did you do? Okay, so I'm going to change one word that you said, Crystal. So we're going to change the word multiply. We're not going to multiply by the reciprocal. We're going to raise both sides to the reciprocal. And there is a difference, okay? When you're raising, though, you do multiply. So we are raising both sides to the 3/4 power, which is the reciprocal of 4/3. That's going to cancel out. And what did you put on the right-hand side? What's happening over here? Trying to evaluate the 16 to the 3/4. No volunteers on that one? Go ahead, Sandra. Okay, so 4/3 of 16 is 2. All right, y plus or minus 2? All right, we have an even root here. So as you take the even root, that's when you put the plus or minus. And what is this still being raised to? The 3rd power, the numerator of our exponent. So we'll get x plus 1 equals plus or minus 8. Subtract over the 1 and combine individually. So positive 8 minus 1 is 7, and negative 8 minus 1 is negative 9. Okay? So that is an example of solving a rational exponent equation. So our exponent was a rational exponent, and we always got to watch out for the evens. So just to restate, in this problem, we had an even root in the denominator. That means plus or minus. What was the other even rule that we have to watch out for when we're solving? Joy?
If you raise both sides to an even power.
Good. So just to restate what Joy just said, if you raise both sides to an even power, power would be in the numerator, you will have to check your answer to make sure it's not extraneous. That was a new vocab word. All right, we're going to keep going on. We have around 8 or so more examples today. They are going to go back a little easier than this and then progressively get a little more challenging. All of the ones for today are going to either be in radical notation or rational exponent notation. So let's do 2 cube roots of x minus 8 equals 0. If you're in period G watching this, you did this problem yesterday already. Sorry, I had to make that side comment. What do we do? Add the 8. Then what? Divide by 2. And how are we going to get rid of a cube root? What would be the inverse of a cube root? Raise it to what? I heard 1/3 and I heard 3. Which one is the correct answer? No. This is already 1/3. Okay? Cube root is a 1/3 exponent. So what would be the inverse of a cube root? Cubing it. You're raising both sides to the 3rd power, not the 1/3. And I'll show you why off to the side in a second. So these are going to cancel, and we're going to get x equals 64. Did we do any evens, powers, or roots anywhere? No, so we don't have to worry about checking our plus or minus. So what I just want to restate at this point right here, when you have the cube root of x, that is the same thing as x to the 1/3. Those are equivalent. So if you try to do the cube root of x to the 1/3, that does not cancel. Right? That's like saying x to the 1/3 to the 1/3, not reciprocals. Do not cancel. It would become 1/9. So incorrect. I'm glad you guys said that, though, because that usually happens to around half the class when I give this quiz. So addressing misconception right there. Watch out for that. Next one. Okay, 2x to the 3/2 equals 250. Going to start off dividing both sides of our equation by that coefficient. You always got to get rid of those coefficients before you do your raising. So we're going to divide by 2. And what do we now have on the right-hand side? 125. And like the warm-up, if it's raised to the 3/2 right now, how are we going to eliminate that exponent? Good. Raise it to the 2/3, the reciprocal. Cancels. And we're going to, do the root first, then the power. What is the cube root of 125? So we have 5, and that is still to the what power? Second. And we're going to get 25. Did we raise both sides to any even powers or even roots on that example? Yes. Which one, power or root? Power. So if we look at what we raised to an even power. That means we are going to have to check our solution. I'm going to show the check. I am okay if you guys check on the calculator or use mental math, but you got to put a check mark at least so I know you checked it. So let's check 25. So we'll have 2 times 25 to the 3/2, and I'm checking, does that in fact equal 250? So we're subbing in 25 back into the original and using order of operations, not opposite operations. So if I were to do order of operations, what do we evaluate next? What are we going to evaluate? Joy? The exponent part. Okay, so we're going to work with a 25 to the 3/2. So what is the square root of 25? 5, and then 5 cubed? 125. So this becomes 2 times 125 equals 250, and we do get 250 equals 250. The left and the right sides are equivalent. This works. Not extraneous. Any questions I can answer so far? Yes, Crystal? Okay, so we will have one of those coming up. So let's pretend you checked and you got like negative 250 equals positive 250. That's a false statement. So what you would do is you'd come over to your answer of x equals 25. You'd cross it out. You would write extraneous next to it and then say that there was no solution to the problem, okay, when that happens. All right. But this one was good. All right. Next example. Negative 4 equals the square root of 2x minus x. Okay. We're going to make a side note next to this. This is a type of a problem where we have an x under the radical and we have an x not under the radical. Those x's at this point in time cannot be combined. So when you have a problem like this, your goal is to still isolate the radical first, just like you would have if this wasn't an x on the outside. So your goal is to move everything away from that radical, including variables. So we're going to add that x to the other side. And what will our left-hand side now look like? What's the left-hand side going to be? X minus 4. Good. Equals the square root of 2x And then we're going to get rid of the radical, just like we did in some of the earlier problems. So how do we get rid of a square root? We square. We are squaring the entire right-hand side, and we are squaring the entire left-hand side. We are not squaring the terms on the left side individually. We're squaring the whole left-hand side. Meaning, how will you do x minus 4 squared? How will you do that out? A little louder. I'm deaf. Distribute how? So there's two ways that you could distribute. One way that's wrong and one way that's right. Joy? Write it out twice. And then you distribute the two binomials, which is FOILing. Okay, you cannot distribute the exponent. That would be squaring them individually. You can't distribute the exponent over addition or subtraction. On the right-hand side, the square root and the square cancel out, and you're left with 2x. And this is now going to end up turning into a quadratic. All right, quadratics are going to be popping up for the rest of this section and future sections as well. So let's go ahead and finish FOILing this out. We're going to get x squared. Let's combine our like terms in our head. You would get a negative 4x and another negative 4x. What does that become? Negative 8x plus 16 equals 2x. What are the three ways you could solve a quadratic equation that you would have learned with Miss M? Quadratic formula, factoring, and square roots, okay? Can't do square roots on this. We have a B term. So you're left to either try to factor it or do the quadratic formula. Anytime the A value is 1, I think factoring is a quicker strategy to try, unless you can't figure out what the factors are. Either way, you got to set it equal to what? 0. So if we subtract that 2x over, we're going to get a negative 10x in the center, now equal to 0. And can anyone find factors of 16 that'll give you a negative 10? Factors of 16 that'll combine to negative 10. Sandra? Good. Negative 2 and negative 8. And if we set those factors equal to 0, what are the two solutions? Positive 2 and positive 8. All right? Something I haven't done yet that I need to do. Go back at look at our work. What did we do along the way? These are the questions you need to ask yourself before you say you're done. We raised it to an even power. What does that mean? We have to check. Now we got two answers. We have to check both of our answers. Okay. So let's show I'm going to show the work up here. Let's go ahead and check the positive 2 first. So we're subbing positive 2 into the original problem. Negative 4 equals the square root of 2 times 2 minus 2. You're subbing the 2 in for both x's. Let's just do mental math real quick together. What's 2 times 2? 4. Square root of 4. So I get negative 4 equals 2 minus 2. And I get negative 4 equals 0. False. So what does that tell us about 2? It's extraneous. We'll go back and label that in a minute. Let's go ahead and check the other solution, because they could both be good, they could both be bad, or you could have one good and one bad. You don't know until you check them. Negative 4 equals the square root of 2 times 8 minus 8. 2 times 8? 16. Square root of 16. So I get 4 minus 8, which is negative 4. So that one was good. So what we will do is come back over to our answer. I'm going to cross off the 2 and write extraneous underneath it, or abbreviate extraneous. And then I'm going to put a box around the 8 to clearly identify that that is the only solution to this problem. Or you can put a pretty cloud or a circle, whatever your preference is. Any questions on that one? Anytime you have this extra x, see that extra x that was under a radical? It's always going to turn into a quadratic. All right, because you're going to end up squaring both sides, and when you distribute, you get a quadratic. number 12. We have the square root of 3x plus 2 minus 2 radical x equals 0. What makes this example different than the ones we've done so far? I strategically choose my examples. I know they seem like a lot, but they all have something different to touch upon. What's different about this one? There's 2 radicals. Okay, so when you have 2 radicals in a problem, they need to be on opposite sides of the equal sign. Okay, so when you have 2 radicals in a problem, they need to be on opposite sides. So right now they're both on the left, so you're going to choose one of them and move it to the other side. I'm going to choose the negative one to get rid of that subtraction. So we're going to add this whole term to the other side. Now the right-hand side has a coefficient of 2. Usually when we have coefficients, we like to divide by them. However, dividing by 2 in this problem will not be useful. All you will be doing is moving the 2 from the right-hand side to the left-hand side. It's not going to really get rid of it. Anytime, this could come up even when we did some of the other problems. If you don't want to divide by 2, you can actually leave it there, and I'll show you what you'll have to do if you decide not to divide. Bless you. So both x's are underneath square roots. How are we going to get rid of the square root? Square it. So we're squaring the left and squaring all of the right. So the left side, they cancel, and we just have 3x plus 2. And on the right side, we're squaring all of it, including the who? The 2. We're also squaring that 2. We're allowed to distribute it because there's no addition or subtraction here. So what is 2 squared? 4. And then the square root and the square cancel, and you're left with x. So if for some reason you don't want to divide by that coefficient, maybe if you divide, it'll give you a fraction or something like that, you can leave it there, but then just make sure when you raise both sides, you also have to raise that coefficient to the exponent as well. Now it's just a linear equation. I'm going to subtract the 3x to the right, and I'll get 2 equals x. Do we have any of our watch out for this in this type of problem? Yes. We did what? Raised to an even power here. So we're going to go ahead and quickly check. So 3 times 2 plus 2 minus 2 radical 2 equals 0. There's 2 ways you can do this check. I am okay with decimals when you check. Under the first radical, 3 times 2 and 6 plus 2. So we get square root of 8 minus 2 radical 2 equals 0. Option 1, change everything to decimals and subtract. So like take the square root of 8, write it as a decimal. On your calculator, do 2 times radical 2, change it to a decimal, and then subtract them to see if you get 0. All right, you can definitely change to decimals. Other option is you could simplify radical 8. Radical 8 breaks into radical 4 times radical 2, which becomes 2 radical 2. So if you have 2 radical 2 and you subtract 2 radical 2, that is going to end up equaling 0. Either way you check it, whether you change the radicals to decimals or try to work with the simplified versions, it should work out either way. So we're good. No extraneous there. I'm going to pause. I have 3 more that I would like to, maybe 4 more depending on where we end up. I'm going to pause for questions. So everyone's 100% understanding what we're doing right now? I got head nods and I got silence. Okay. Next one then. 4 times, or the 4th root of 2x plus the 4th root of x plus 3 equals 0. So like number 12, we have how many radicals? 2. Does it matter which one you move to the other side? No. I'm just going to move the first one. When I move it over, it's going to become negative, okay, because we're subtracting it over. If we have fourth roots, what will we raise both sides to?
4.
To the fourth. Not 1/4, but 4. Raise the left to the fourth, raise the right to the fourth. We're going to have x plus 3 equals, and the point I want to make on this example is when you're raising the right-hand side to the fourth, you're also, again, raising that coefficient, and this coefficient is a -1. So what happens when you raise a -1 to the fourth power? What will happen to it? It'll become what, Sandra? It becomes 1. It becomes a positive 1. Okay, so -1 times -1 times -1 times -1, it becomes a positive. So that negative is just going to end up going away when you raise it to the fourth, because 4 is even. What if you raise both sides to the third power? Would it become positive? No, it would stay a negative in that case. So we're going to have just 2x, because those cancel, and the negative turns positive. And if we solve here, we're going to subtract that x over, and we're going to get x equals 3. Anything else, or are we done? We have to check. Okay, fourth power right here, even power. Let's check it. So I'm subbing it into the original problem. The fourth root of 2 times 3 plus the fourth root of 3 plus 3, checking to see if that equals 0. I'm going to get the fourth root of 6 plus the fourth root of 6 equals 0. You can stop right here. You could change them to decimals using your calculator, but there's no way if you have a positive number plus another positive number that that's going to come out to be 0. It's just not possible. If you leave this in radical form, if you have one fourth root of 6 plus another fourth root of 6, you end up with 2 fourth roots of 6, which does not equal 0. So we're going to come over here to our 3. We're going to cross it out and write extraneous next to it. And if the only answer you got was extraneous, therefore there is no solution to the problem. Yes, Quentin? So x equals 3 from this step to this step? Okay. So I subtracted over this x to the other side. So this 3 is coming down. And then 2x minus x is 1x. Okay. Any other questions on that one? Okay. You could also do some sort of common sense. I'm going to teach you some things to watch out for. When you're working with even roots, okay, even roots, an even root, when you evaluate it, can never come out to be a negative. So that should be a red flag right there that you're probably going to have an extraneous solution when you have an even root equal to a negative something. What are we at, number 14? So the square root of 2x to the fourth plus 5 equals the square root of x to the fourth plus 13. This problem, the radicals are already on opposite sides of the equation. And this problem is going to be a double solve. Because not only do we need to get rid of the radicals, but once we get rid of the radicals, underneath, there's still a power we have to get rid of. So we're going to be raising twice on this example. What are we going to raise both sides to first? 2. Okay, square, square. And that means we're going to have to eventually check our answer because that's an even power. We're going to be left with 2x to the fourth plus 5 equals x to the fourth plus 13. We're going to move the x's to the same side. So I'm going to subtract the 1x to the fourth to the left. And if I have 2 and I'm subtracting 1, that's going to leave me with 1. From here, going to do from here? Subtract the 5. Then what? Find the fourth root of 8. Okay. Now, there is not a perfect fourth root of 8. There's a perfect third root of 8, but not a perfect fourth. So from here, I'm not going to leave it in this notation. We are going to go ahead and rewrite it as a lower base. That was probably the one skill on the quiz yesterday that you guys struggle with most, remembering to look to see if you can rewrite something as a lower base. So how could you rewrite 8? How could you rewrite 8? 2 to the third power. Also, we are taking an even root. What does that mean? Even root means plus or minus. So we're going to have plus or minus 2 to the third to the 1/4, which equals plus or minus 2 to the 3/4 when you multiply. So this is a plus or minus problem, but it's also, as we noted earlier, a check problem. Okay, this is going to be a little messy to check. Things are going to cancel pretty quickly, though, so it's not going to be too bad. Let's go ahead and check the positive first, and then we'll check the negative. So we're subbing it into the original problem. 2 times 2 to the 3/4 to the 4th. So I'm subbing 2 to the 3/4 in for that x right there, plus 5. And I'm checking to see if that equals 2 to the 3/4 to the 4th plus 13. So as I just said, things are going to cancel pretty quick. You see this fourth power and that fourth root? What's going to happen to them? They're going to cancel. And we're just going to be left with 2 to the third. What is 2 to the third? 8. So this is going to become 2 times 8 plus 5. Let's do some work on the other side. The 4's again are going to go ahead and cancel. And you're going to be left with 8 plus 13. 2 times 8, 16 plus 5. So I get 21. Square root of 21 equals the square root of 21. So it works. Okay. Now the negative. I'm not going to show the work for the negative, but the negative also works. So negative 2 to the 3/4 is also going to work. And I'm going to tell you that it works because if you sub it in, the only difference is that negative sign, right? And because this is a fourth power, what is that fourth power going to do to that negative? It's going to make it positive, and then it's going to be the exact same thing that we just did. So if you sub in the negative in for x, this fourth power right here is going to change the negative into a positive, and it'll be the exact same check. So both do work. Okay. So I have 2 more. Almost done, guys. This one we're not going to do all the way out. I'm going to put a little dot, dot, dot there, and I'm just going to tell you what the answer is to this problem. You're going to get 2x equals negative 6, and you're going to get x equals negative 3. Okay. So if you actually did this out, you will get x equals negative 3. You would have squared both sides, which means you would have to do what to this problem? Check it. So I want to focus on the check. So if I sub in negative 3, 3 times negative 3 plus 1 equals negative 3 minus 5. On the left, we're going to get negative 9 plus 1, which is the square root of negative 8, equals the square root of negative 8. Now, that's a true statement, right? Okay, square root of negative 8 does equal square root of negative 8. However, you took a real number and subbed it in and you're getting out an imaginary expression. So even though the check works, because the check is imaginary, that also is another case when your answer is going to be extraneous. So if you check and you get imaginary, it's also extraneous. No solution. That's what I wanted to emphasize on that example. How much time do we got? 10 minutes? Yes. I'm gonna pause. Any questions? You guys are so quiet today. Am I moving too quick? No? Tired? Yes? Okay. Let's finish this then. The square root of x minus 4 equals the fourth root of 12x plus 16. Why am I choosing this one? They're different roots. Okay? When you have different roots, you are going to raise to the least common multiple. Okay, so we have a square root, which is 2, and a fourth root, which is 4. So what's the least common multiple of 2 and 4? So 2 would be the greatest common factor, not the least common multiple. 4. 4 would be the least common multiple. It's what they both go into, not what goes into them. So, for example, what would be the least common multiple of 2 and 3? 6. You would raise both sides to the 6th power. Okay, so we're going to raise to the least common multiple, and in this case, the LCM is 4. So we're going to raise the left side to the 4th and the right side to the 4th. They do not cancel on both sides. They only cancel on what side? The right. On the left, excuse me, thank you. Anyone want to take a guess on what happens on the left? What happens to the square root raised to the 4th power? No? Doesn't double. It might be easier to see if I rewrote it like this. So I'm going to rewrite it in rational exponent notation. How do you rewrite a square root as an exponent? How do you rewrite a square root as an exponent? 1 over 2. Okay. That's not an opposite operation. That's just rewriting it in a different form. And then we just raised it to what? The 4th power. Okay. So I think this might be easier to see it in. So if I rewrite it like that, what would you do with the 1/2 and the 4? What operation? Multiply them. So what is 1/2 times 4? 2. Okay. So that's going to become, on the left, x minus 4 squared. So we will have to go ahead and FOIL that out in a minute. And on the right-hand side, they canceled. If we FOIL on the left, do x minus 4 times another x minus 4, we're going to get x squared minus 8x plus 16, same expression that we had earlier, equals 12x plus 16. Now what? You could move things to the right, but when you have an x squared, you want to move everything to the side that the x squared is on. So let's go ahead and move the 12x and the 16 to the left-hand side. So we're going to subtract that b term, subtract the c term, and set the quadratic equal to what? 0. Okay, because there is a b term, we can't solve by square roots here. That's going to give us x squared minus 20x equals 0, because the c terms cancel out. When the c terms cancel out, you still could do the quadratic formula if you wanted to, but it's much easier to factor, because the only way, or the quick way to factor when there's no c term is by factoring out the GCF. What is the GCF in this problem? X. So if we factor out an x, we are left with x minus 20. and if you set each factor equal to 0, what will the two solutions be? If you set x equal to 0, then what does x equal? 0. That first factor from a GCF, as long as there's an x there, will always give you 0 as a solution. And what about the other solution? X equals 20. This was a check problem. We raised both sides to the fourth power. But to save some time, let's just go ahead and mentally check. We're not going to write down the check on this one. So let's sub in 0 first into the original problem. What is 0 minus 4? Negative 4. Do we have to keep going any further? No. When you sub in 0, you're going to get a negative underneath a square root, which is an even root. That means it's already going to give you imaginary. So that's out. If we look at the other one, let's sub in 20. What is 20 minus 4? 16. And square root of 16? 4. Okay, keep that in mind. When we check the left, we got 4. Now let's do it on the right-hand side. I'm going to get my calculator out here. So we have 12 times 20 plus 16 is 256. And then what is the fourth root of 256? 4. So we do get 4 equals 4. So 20 is good. 0 is extraneous. Okay, we're going to stop there. I'm going to stop recording. I do want to say just a couple things about yesterday's quiz.